Hello everybody. Today I'm going to be talking about nodal analysis. Here, let's start off by talking about junctions. What exactly are junctions? And pardon my sloppy line tracing, I'm not very good at it. But essentially, junctions are wires that are connecting multiple different components together. They each have their own separate voltage compared to all the other wires, and we obviously need to consider them with respect to the ground node. So I'll talk about what that means in just a moment. This is the ground node, so everything that is connected here is considered to be 0 volts. This red wire here has a voltage level that is 10 volts higher than 0 volts. So what exactly is the voltage level of this red wire? 10 volts. Now notice the voltage of this red wire is completely different from the voltage of the blue wire, and it may be different with these wires. We just don't know, but most likely it will be. Just act like these wires are all separate voltages, and that's pretty safe to assume. Before I begin, I think it's helpful to try and envision what exactly I'm doing over here. I am drawing on these 3 nodes, which we don't really know the voltage levels of. Since we know the red one and we know the blue one, we don't know the orange, green, and yellow ones. So that's why I've decided to draw arrows that are pointing away from the resistor into the wire, as you can see, for all of these unknown nodes. And for this one's a special case. I'll talk about this one later. Yeah, for now, let's go ahead and talk about how we're going to form the nodal equations. I typically assume the equation to look something like this. So over here is a bow and arrow. We have the V tail, we have the V head, and we have the resistor R. Typically, the way I form each term in the nodal equation is V tail minus V head over the resistance. So let's go ahead and do a sample run here. Let's take a look at this one in particular. We know that this one's going to have V tail at 0 volts minus V head at, let's say this is called V2 and the green one is called V3. So V2 over, what's the resistor in the middle? 20 ohms. So that's going to be the first one. Let's try another one. V3 minus V2 over 220. So it's going to be in this direction. And plus 10 minus V2 over 150. All of this is to say that they all add up to 0. So therefore, we don't really need to be too scared about that. We can just leave that alone. And another thing is that we're assuming current directions. I can't tell you with absolute certainty that the current is going in this direction. I can't tell you with absolute certainty that it's traveling in this direction. I certainly cannot tell you that it's traveling in this direction. All of these are assumptions, but they're all safe assumptions because it does not matter if you are wrong. Stick with a convention, preferably this one, and don't change it. Let's go ahead and do the same thing for V3. V2 minus V3 over 220 plus 0 minus V3 over 220 plus V1 minus V3 over 1000, and all of this is to say this is all equal to 0. So there we go. We now have the equation for this node and the equation for this node. Let's go ahead and talk about the last equation. Start off by writing the known ones, the easy ones. 10 minus V1 over 220 plus V3 minus V1 over 1000. And lastly, we're gonna add some term here. Is equal to 0. I want to talk about this a little bit. So we see that this voltage controlled current source is actually flowing downwards, right? And we're assuming that it's flowing upwards. So we're clearly wrong. And because we're wrong, we're going to have to put a minus sign. So essentially, it's going to be minus V1. Because it's not flowing up, it's flowing in the negative direction of up, which is down, with a magnitude of V1 amperes. And if all of the amperes must sum up to 0, then there you go, you have your equation. With that being said, these are all the equations that we have. We have 3 equations and 3 unknown node voltages. And our goal ultimately is just to find the voltage drop across the 20 ohm resistor. So our goal is ultimately to stick a voltmeter over here and find what voltage level that is. So we can go ahead and solve that by using the system of linear equations, which is an absolute pain to do by hand. So I'm going to call upon the powers of the animator in order to animate this segment of the video for me. Okay, so we first copy the first row and then split the fractions denominators 220 and 1000 like so. Then we will need to reorder the terms like so that way we can factor out the v1 and replace everything with 1s where there were v1s. Do the same thing for term v3 and subtract 10 over 220 on both sides to get that negative fraction on the right side. Simplify the big scary fraction, and lastly tack on a 0 to that non-existent v2 term. Put it back, and we do the same thing for the second row. Start by copying everything and removing that 0 and splitting the fractions where appropriate. We're going to reorganize the terms and reorder them, factor out the v2 like earlier, and then factor out the v3. And then we're going to move that 10 over 150 onto the other side, tack on a 0 to the non-existent v1 term. And again, simplify the big fraction term and put it back. Again, we copy the third row. We'll start by deleting that 0, and then we split the fractions denominators, duplicating the 220 and 1000 where appropriate. Let's reorganize the v1 term and push it all the way to the front, factor out all of the voltage terms like we have done earlier, and simplify the big scary looking fractions, and then move it back into the third row. Alright, so now we know how to get these nodal equations, and we also know how to solve them. We can easily put them into a coefficient augmented matrix such as this one and take the reduced row echelon form to get this result. If you don't know what on earth I'm talking about, I highly recommend checking out the other video that I made on Gaussian elimination so that you could easily solve system of linear equations such as this one and get your answer. Concerning the question, it's asking us to find the voltage drop across the 20 ohm resistor. So what does that mean? That means that if we were to stick a voltmeter over here, what would that voltage drop be? What's the difference in voltage between this yellow wire and the blue wire? Another way of thinking about it. So the difference between that is V2 minus whatever this blue wire is, and oh look, it's 0 volts because that's our reference, right? So therefore, this is going to be our final answer. And V2 minus 0, as you may intuitively see, is just, well, V2. So therefore, the question is really just asking, what is V2? And if we look at this, we know that V2 is our second column. Therefore, our answer is also going to be our second row. Therefore, it's approximately 1.1271 volts. So we could also go ahead and check this by using a circuit simulator. Alright, so over here, I've actually simulated the circuit, as you can see, and indeed, V2 happens to be approximately 1.127 something volts. So we know that we've done that correctly. Now that we have that, we can easily tell that our answer is correct, and we did everything correctly, which is great. But now, suppose that I bring up another question. Let's say that I said, instead of finding the voltage drop across this resistor, how do we find the voltage drop across this resistor instead? Right, so if we were to stick a voltmeter over here, what would that read? That's the question I'm trying to ask. And again, that's pretty trivial. All we need to do is we just need to look at the third column, and now we look at the third row, and now we know V3 and we know V2, and we're essentially saying what's the difference between V2 and V3. That's our answer. So we take a look at these two and we subtract it, we get a difference, and therefore we now know the voltage drop across these two. Obviously we could measure it like this, plus minus, which means that V2 is higher or considered higher than V3, or we could also consider it minus plus, where V2 is lower and it's actually V3 minus V2. Pay attention to the signs. The plus one is always going to be the first term. So for example, because it's minus plus, it's going to be V3 minus V2. Right, so now that we know the basics of voltage and acquiring voltage levels, what happens if we're told to find current? So for example, if I said, what is the current through the 220 ohm resistor? Easily, we could just take, well, V3 minus V2, whatever that is going to be, and 220, and we can tell, is it actually flowing from V3 to V2, right? Because we're assuming V3 is higher. So is it flowing this way or is it flowing this way, right? So now what we can do is we can take this and we can actually go ahead and plug it in. And as it turns out, our initial guess that V3 minus V2 going in this direction happens to be wrong. It actually happens to be flowing in the other direction because V3 is less than V2. Thus, if we were to actually subtract it, we would get 0.512 minus 1.12 over 220, and this would give us a negative answer. And that negative answer indicates that it's actually flowing the opposite direction of this. And that means that it's just flowing this way. Therefore, we would get a numeric answer, and also the plus and minus sign in the front will tell us the direction of the current. Alright, so that pretty much wraps up nodal analysis. In a future video, I'm going to be covering mesh analysis. See you in the next one.